Hello everyone, myself Swamiraj Chavan and our project name is Development of Model Rocket, and my team includes Vishal Tambe, Urvi Rana, Pawan Kedar and myself Swamiraj Chavan. So we are making this model rocket to make rocket sector and space sector accessible to everyone, and application of this model rocket project is we can check real-time data from the height, we can check altitude, we can check the climate and humidity, and also we can check different location where the rocket is, and it can be useful for farmers and many other purposes.
I will be explaining about various part of our model rocket. The first topmost part of our model rocket is nose cone. It has an ogive shape which helps to reduce the aerodynamic drag, which reducing pressure impact on body. It helps the rocket to cut through air easily. The next part is the body tube. It is the main body of the rocket. It consists of payload and recovery system. The recovery system has a parachute which provides safe landing to the rocket. The payload is the part where real-time data monitoring is done. It has the main avionics system which has various sensors and microcontroller. The bottom part of the body tube is designed to fit the motor. Then there are fins attached at the bottom of rocket. It provides balance and direction to the rocket. The shape of the fins differ as the shape and size of the rocket varies. The whole rocket has to be placed on a launch rod. It provides support for stable launching of rocket. It has flame deflector which deflects the flame away at the time of launching.
I'll be taking over with the simulation part of this project. We used a software called OpenRocket for the simulation. It is commonly used by rocket enthusiasts to design and simulate rockets even before actually constructing or designing it. It allows us to learn if the design will actually work or not. It includes various factors like liftoff or launching, apogee, which is the maximum height or altitude of the rocket, and how far it will land, and many other factors.
This is the 3D model that we designed. We can view it in different views like 3D unfinished, 3D figure, back view and side view. We can add components from here. All the parameters of various components can be adjusted by double clicking on the component like this. The software also has its own database from which we can select ready-made motors or designs. We can also add motors. We can choose the motor from the database as well. Once the simulation is completed, we can adjust the environmental conditions like wind speed, standard deviation, turbulence intensity, wind direction, etc. The software simulates the flight and gives results according to the parameters we give as input. It also plots the graph of flight. We can change the center of gravity by adjusting parameters. We can simulate multiple times until we get desired output.
I am explaining about the avionics system in model rocket. Avionics refers to electronic use for the aviation. It consists of flight computers, controllers, sensor, communication system, guidance and control system, and flight software. It also consists of power systems like batteries and power regulators. In avionics, we use the ESP32CAM AI Thinker chip, which consists of the camera and having capability to interface different sensors and having external storage availability for the storage of the readings and camera snaps. We have used the different sensors like temperature, pressure, gyroscope, camera, etc. We have used the BMP280. It is a temperature sensor. It measures the atmospheric pressure as well as the temperature and at the different altitudes. We have also used the gyroscope MPU6050, which can be measures the angular displacement of the flight during its travel. By using all these sensors, we can measure the temperature, pressure and the angular displacement while the traveling of our model rocket.